Alright, so armed with our knowledge of logarithmic functions and how they behave, their properties, their inverse properties, etc., we're ready to actually solve a larger bank, if you would, of logarithmic and exponential equations. So let's begin with logarithmic equations, and basically the idea is you want to try to convert, right? So the idea is we'll first try to get one logarithm statement, and then once we have that one logarithm statement, we convert it to an exponential equation. So that's basically our strategy when solving a logarithmic equation. So looking at this first, I see that I have a sum, right, of two logarithms. So our property says that that creates the logarithm of a product. So this becomes log base 2 of x times x plus 2, right, equals 3. And if you wanted to, we can say this is log base 2 of x squared plus 2x equals 3. So now that I have it in one logarithm, we can change it to its exponential counterpart. So we're basically saying that 2 to the third power is equal to x squared plus 2x. And so now what we have is a quadratic equation to solve. Let me flip things around. We have x squared plus 2x equals 8. Move the 8 over, we got x squared plus 2x minus 8 equals 0. In this case, we have a factorization. So when I factor it, I get x plus 4 and x minus 2 equals 0. And so we basically have two potential solutions here. This one gives us negative 4, and this one gives us 2. All right. However, at this stage of the game, we have to make sure that the logarithm is defined. So recall that the log, right, especially this one right here, the domain is from 0 to infinity. Right? We have to make sure that whatever goes inside of these doesn't, logarithms can't handle negative numbers, basically. All right, so that's from our knowledge of the domain of the logarithmic function. So that means this guy is out of the question. It's what we call extraneous. So this one's extraneous, right? But that's the one that works. So this does have a solution. The solution is that x equals 2, and there's basically our strategy. So write it as one logarithm, make a conversion, and then solve what's left. And in this case, we had a quadratic. The next one, we have a difference. So with the difference, that means we're actually dividing. So this becomes the log of x plus 1 over x minus 3, and it equals 1. And so there's basically our one logarithm. Changing it to an exponent, my base is 10. So 10 to the first power is equal to what's inside there. All right, and so that's just basically 10. 10 to the first power is 10. So we basically have a rational equation to solve. So the way we did that is we usually multiplied both sides by the LCD, cleared that out. We get x plus 1 equals 10x minus 30. And then we start moving some things around. We can subtract 10x and subtract 1. And we get a negative 9x equals, looks like negative 31. Divide by negative 9, and we get x equals 31 over 9. I'm trusting that value because when I plug that in here, 31 over 9 is definitely over 3. So, you know, it's like 3 point something or other, because 9 goes into 31 3 times a little bit more. So here, that's still positive, and that's still positive. So I'm pretty confident. I'm trusting my math. That is the solution. It doesn't cause any domain errors for the logarithms that are given. So there's our solution for that guy. Next one, again, we have a sum. So putting this together, it's the natural log of x, and x plus 2 is equal to 1. And this is basically a natural log of x squared plus 2x equals 1. This is a base e. So once I now have it as one logarithm, I can convert it. So we're basically saying that x squared plus 2x is equal to e to the first, which is just e. And it's an oddball, right? Because if I move that over, we have x squared plus 2x minus e equals 0. And the good news is it's a quadratic. We know how to solve a quadratic. The bad news is we have a quirky number, right? We haven't really quite seen that irrational number. So definitely the way we're going to solve this is probably completing the square or using the quadratic formula. Those will be our two ways that we can solve a quadratic for any situation. Since this is a lead coefficient of 1 and that is a 2, I'm going to go ahead and complete the square on that. So let me move the e back over there. Right, we're going to take 2, take that value and square it. So to complete this square, I need to add 1 to both sides. This is x plus 1 squared. So take a square root, add a plus minus. We get x plus 1 equals plus or minus the square root of e plus 1. Subtracting 1 from both sides, we basically have x is negative 1 plus or minus the square root of e plus 1. Alright, and so we have two potential solutions, negative 1 plus the square root of e plus 1, and x equals negative 1 minus the square root of e plus 1. Okay, so quite a quirky number. And again, thinking in terms of domain, right, this guy at least needs, again, to stay positive, and this also needs to stay positive. And so when I'm looking at this, this is negative 1 minus the square root. So this is definitely less than 0. So that one is extraneous. And this one here, again, we at least have the square root of 1 and e is 2. So I believe this is going to be greater than 0. So that is our actual solution, right? Whatever that crazy thing turns out to be. Of course, we can turn to our calculator and get an approximation, but that is the exact value, right? So kind of an odd thing there, but you can kind of see at some point we're back to doing earlier things in our course, solving quadratics, solving rationals. Maybe we get a linear equation if we're lucky, but that's basically what happens. Right, so D, last one, starts off a little tricky because I have logarithms on either side. Right, so probably our first move is to collect all the logarithms to one side so I can use my properties. So how about we begin this by subtracting log base 3 of x minus 4. So this side will get 2, and over here I'm going to go ahead, we have a log minus a log, so that's log base 3 of their quotient. Okay, and then now that I have one logarithm, I can convert it. So 3 to the second power is equal to that guy there. All right, and so we have a rational expression to solve. So we do that by multiplying both sides. So we get x plus 1, that's 9 times x minus 4. So we get 9x minus 36. And then we start doing our work here. So subtract 9x from both sides, subtract 1 from both sides. We get a negative 8x equals, it looks like a negative 37. Divide both sides by negative 8, and we get x equals 37 over 8. All right, and so 8 goes into 37, a little over 4, right? Because 8 times 4 is 32. So this is like 4.5-ish. So that stays positive and that stays positive, right? Despite that subtraction, our number is a little bit over 4. So that one doesn't cause any domain errors for my logarithms, so we're done. All right, so there is basically how we solve logarithmic equations. Again, the strategy is to use our logarithmic properties to convert it all into one log. And then once we have that, we convert it to its exponential expression. And then we solve that remaining expression that we get. So pretty heavy-duty problems. Because we just quite don't know. I mean, sometimes we end up with a quadratic to solve. Here we end up with a rational. You could imagine we can probably end up with a radical or a linear. Anything can come up, all right, including some weird cases of quadratics. But again, nice review, hopefully, of how to solve quadratics. We've been doing that for quite some time now. So there's logarithms, all right. So let's go ahead and turn to exponents and some other issues with regards to 6.6. See you in a video coming soon.